Boiling acid, crushing ocean pressure, deadly cosmic radiation, frozen, barren deserts that are significantly colder than the darkest winters of Antarctica. If a human being were dropped into any of these environments, our biology would fail almost instantly. Our cellular membranes would rupture, our proteins would violently denature, and our DNA would completely shatter.
You would die in a matter of seconds. Yet, hiding within these apocalyptic conditions, some organisms do not just barely survive, they actively thrive.
For decades, the greatest minds in science believed that life was incredibly fragile. We thought it could only exist in perfect, gentle, Earth-like conditions. But a hidden class of indestructible organisms, known as Extremophiles, shattered that assumption forever. And in doing so, they have completely transformed humanity's search for alien life across the cosmos.
Hi Questers, welcome to QuestHut. Today we are embarking on a journey to explore how Earth's most bizarre and resilient organisms forced astrobiologists to completely rethink one of humanity's biggest and most terrifying questions. Are we entirely alone in the dark universe?
To understand just how revolutionary extremophiles are, we first have to look at the old scientific paradigm. Historically, astrobiologists were incredibly strict about where life could exist. They operated under a concept known as the Goldilocks zone. This is the precise orbital distance around a star where the temperature is just right. Not too hot, so the water does not boil away, and not too cold, so the water does not permanently freeze. Scientists assumed that life absolutely required an abundance of warm sunlight, atmospheric oxygen, moderate surface temperatures, and a highly stable environment. The logic made perfect sense at the time. All life as we knew it relied on liquid water as a universal chemical solvent. Water is the magical medium where molecules can float, interact, and build the complex structures necessary for biology. Because of this, early space exploration was essentially searching the galaxy for strict Earth clones. We believed that the vast majority of the universe was a completely sterile wasteland. Extreme environments, whether deep underground, at the bottom of the ocean, or irradiated by the sun, were considered entirely dead zones. But then, in the late 20th century, scientists began looking closer at our own planet, and they started discovering complex biological life in places that should have been completely, utterly dead. Enter the Extremophiles. The word literally translates to lovers of the extreme. These are organisms that have evolved radically different biochemical machinery, perfectly adapting to conditions that would instantly annihilate normal life. Let us begin our descent into the extreme by looking at the heat lovers, scientifically known as hyperthermophiles. For a long time, biologists believed that if you heated a living cell above boiling, the heat energy would simply melt the lipid bilayer of the cell wall and cause essential proteins to unfold and fall apart. But deep at the bottom of the Pacific Ocean, resting along the edges of violently active volcanic fault lines, scientists discovered towering structures called hydrothermal vents, or black smokers. These vents spew toxic, mineral-rich fluid heated by the Earth's magma to temperatures exceeding 350 degrees Celsius. And clinging to the sides of these boiling, toxic chimneys is an organism called Pyrolobus fumari. It lives comfortably at temperatures well above the boiling point of water. To survive, this organism has evolved a completely different molecular architecture. Its cell membranes are fused together with unique chemical bonds that act like molecular armor, preventing the cell from melting. But even more incredibly, living at the bottom of the ocean means there's absolutely zero sunlight. For billions of years, we thought all food chains had to start with photosynthesis from the sun. These vent ecosystems proved us wrong. They use a process called chemosynthesis. Instead of eating sunlight, they eat the toxic hydrogen sulfide gas bubbling up from the Earth's core, converting that raw chemical energy directly into life. Next, we must examine the radiation survivors. Radiation is the ultimate enemy of biology because high-energy particles rip straight through physical matter, violently smashing into the delicate double helix of our DNA, shattering it into pieces. But then we discovered Deinococcus radiodurans. It is affectionately known by scientists as Conan the bacterium. This microscopic marvel can withstand doses of gamma radiation thousands of times higher than the lethal limit for a human being. If you expose this bacterium to massive radiation, its DNA is blown apart into hundreds of tiny fragments. It should be dead. But Deinococcus radiodurans simply gets to work. It keeps multiple backup copies of its entire genome safely stored away. Within a matter of hours, it uses specialized proteins to grab the shattered pieces of its DNA and perfectly stitch them back together, flawlessly reassembling its genetic code. This proves a terrifying and beautiful point. Life is capable of surviving intense, prolonged cosmic radiation.
But what about the cold? Freezing is just as deadly to cells as boiling. When water freezes inside a living cell, it forms sharp, jagged ice crystals. These microscopic ice daggers physically puncture the cell walls from the inside out, causing the organism to rupture and die.
Yet, scientists drilling deep into the ancient permanent ice of Antarctica have found thriving communities of psychrophiles, or cold-loving microbes. To prevent themselves from being shredded by internal ice crystals, these microbes manufacture their own biological antifreeze. They pump their cells full of specialized cryoprotectant proteins and sugars that drastically lower the freezing point of their internal fluids. Some of these microbes have been found trapped in permafrost, remaining in a state of suspended animation for hundreds of thousands of years, just waiting for the ice to melt so they can wake up and divide again. Finally, we must look at the ultimate survivors of the void, the microscopic tardigrade, also known as the water bear. Tardigrades have been subjected to the most brutal conditions imaginable. They have been boiled, frozen to near absolute zero, crushed under immense pressures, and even strapped to the outside of orbiting rockets and directly exposed to the cold, irradiated vacuum of outer space. And they survive. They achieve this through a miraculous biological process called cryptobiosis. When a tardigrade senses that its environment is becoming completely hostile, it forcefully expels almost all the water from its body. It pulls its microscopic legs inward and curls into a tiny dehydrated ball called a ton. It then floods its cells with a unique sugar called trehalose, which essentially turns its internal organs into a biological glass, pausing its metabolism entirely. It can sit in this glass-like state of suspended death for decades. But the moment a single drop of water touches it, the glass dissolves, the organism rehydrates, and the tardigrade simply walks away as if nothing ever happened. Suddenly, the biological world realized something profound. Life is not fragile. Life is an aggressive, relentless force of nature that refuses to be extinguished. And this realization sparked a massive scientific revolution in the field of astrobiology. The old question was simple: can Earth-like life exist elsewhere in the galaxy? But because of Extremophiles, the new question became infinitely more exciting. What entirely different kinds of life could exist out there? We used to look up at the stars and think that life was incredibly rare, a delicate chemical accident clinging to a perfect, fragile blue marble. But now we know the truth. Life is not rare. Life adapts aggressively. Life finds a way to build complex biology out of toxic gas, crushing gravity, and deadly radiation. The universe does not need gentle, Earth-like conditions to create biology. The truth is, we were simply imagining life much too narrowly. As scientists continue launching probes, scanning distant exoplanets, and searching hidden subsurface oceans, the most important discovery regarding alien life may have already happened right under our feet. Because Extremophiles taught us something beautifully extraordinary. Life pushes violently into every possible corner of reality. Into the crushing darkness, into the boiling acid, into the freezing void, into environments that human arrogance once declared completely impossible.
And if biology can thrive in the places on Earth we once called dead, then maybe, just maybe, the vast universe above us is far more alive than we ever dared to imagine.
What do you think? If alien life truly exists out there in the dark, where do you think humanity will discover it first? Hidden in the deep oceans of Europa? Buried in the salty aquifers of Mars? Or somewhere even stranger that we haven't even thought to look at? Comment below.
And if you enjoyed this massive deep dive into the resilient mechanics of astrobiology and the absolute limits of life, subscribe to QuestHut. Keep asking incredibly difficult questions daily. Keep boldly exploring the vast, terrifying unknown. And I will definitely see you soon.